So you can use your scratch paper that you have, and I'm just going to make this just like a blank screen. And the first thing we're going to do is just kind of remember what we were doing before break. And before break, one of the types of questions I would give you something like this: x squared minus 3x plus 2 divided by x minus 2, and I would say simplify that. So in order to simplify a rational expression, you need to look at the numerator and denominator, and you would want to first factor anything that you can, and then once everything's in factored form, if you have the same thing in the top as you have in the bottom, then those things can cancel out. So let's think back to factoring. Factoring sounds like, okay, it's a one-step process, but each polynomial can be factored differently. You can factor by taking out a GCF. You can factor trinomials if you have an x squared, an x, and a constant number. You can factor by grouping if you have 4 terms. I mean, there's a bunch. There's 7 different ways to factor, which makes it even more confusing. So you have to understand the pattern at this point, look at what the polynomial is, and then figure out what type of factoring can you use. So this is a trinomial, which means you're looking at this last number here, which is 2, and you're trying to figure out the factors of 2 that at the same time add to be the middle number here. So side work would mean take this 2 here and list the factors. Now thankfully 2 only has one factor, well 2, 1 in itself. And we need to take these factors and figure out how we can somehow get a negative 3 by adding them together. Now if I add a positive 1 and a positive 2, that would equal positive 3, but we need it to equal a negative 3. I also need to multiply this number times this number and equal positive 2. So the only way we could have that happen is if both of these factors are negative, since negative 1 times negative 2 is this positive 2 that we need, and negative 1 plus negative 2 is negative 3 here. Once you find the lucky factors that do exactly what you need them to do, you then have to memorize that you will put it into a specific format. The format is going to be x minus 1, since this is a negative 1 factor, times x minus 2, since that's a negative 2 factor. The denominator cannot be factored. You can't take a GCF out of everything because they don't share any common factors except 1, and that's really not going to be helpful for us in this problem. So once we have it factored, then I can actually start canceling things out if you have the same exact factor in the top as you do the bottom. You can't cancel out like this x with this x or this positive 2 with this negative 2 because it's not all in factored form. Now that the top is in factored form and technically the bottom is in factored form, we can cancel out anything we see in the top as we do in the bottom. And what would that be? Yep, x minus 2's cancel, and this simplifies to be x minus 1. This is the final answer, and this is what we were working on before spring break. Simplifying rational expressions which are made up of polynomials. We do this with factoring. But not all of the time does it end up working out that a polynomial can be factored. Sometimes they're not factorable, and you have to use a different process, and that's the unfortunate process we're going to learn today. It's really hard, and it requires you to memorize some steps. There's 2 methods. That's why it's called polynomial long division and also synthetic division. We'll most likely be learning synthetic division tomorrow. That's easier. Today is going to be a little bit more difficult. So I'm going to show you the same problem, how we would solve the same problem using long division. But before I do that, I feel like we need a recap of how to even do long division. So in your actual packet, so we'll go back to the packet now. In your actual packet, we'll skip this top problem here, but we'll do this problem in our packet. 6,584 divided by 24. Now, even though I'm showing you the process, I'm still going to be using a calculator to help me figure out like how many times this goes into this and this goes into this, because I don't know. Sometimes like you still need that calculator to help you, but you need to understand the process to be able to do this next section. So if you remember from way back when you first learned this, I don't even know if 4th grade is really when at this point. I know with Common Core and all the changes, it might be different. And maybe you guys even learn differently. I don't know. But here's how I learned how to do long division. So when you're dividing a first number by a second number, we're used to seeing it in this format, 6,584 over 24. That's the way our questions have normally looked. Obviously, there are polynomials on the top and bottom. But using long division, we use something else. We use like this division sign. We put the first number here, which is the numerator, inside. And what we're dividing by goes on the outside. And when you're using the long division process, you're basically figuring out how many times does this go into this? How many times does this go into this? And it works with regular numbers like this, and it works with polynomials, which is what we'll do next. So when you go to do long division, you think to yourself, how many times does 24 go into the first number? Well, 6 is smaller than 24, so we have to use not just the first number, but the second number as well. So we're going to think, how many times does 24 go into 65? So this is where you can use a calculator to help you. If you can think about 24 times 1, 24 times 2, 24 times 3, 24 times 4, you might be able to figure out in your head, but if not, do the opposite. Do 65 divided by 24, and I can show you what that will say in my calculator. It says 2.708333 if I do 65 divided by 24. That means that 24 goes into 65 only 2 times, and then some change. So what I would do is put a 2 here at the top, and then if you remember, the next step is to take this outside number, 24, multiply it by 2. 24 times 2 is 48, and then you subtract. Now, you're only subtracting the 65 minus the 48. So when you go to subtract, again, you can use your calculator as an aid to help you. If you're feeling like, oh, cool, I remember this stuff, and you want to do old school subtraction, that's fine too. This is going to be 17. After you subtract, we follow this process again. So we think to ourselves, how many times does 24 go into? We look at this number down here now. 24 can't go into 17 because 17 is smaller than it. Does anyone know or remember what we do next?
Bring down the 8.
Yes, so we bring down this 8 here, and now we think of it as 178. And this is where you want to use your calculator to help you because, like, even me, I don't know how many times 24 goes into 178. So I'll do 178 divided by 24. It is. It's 7. So I put a 7 up here. And then I follow this process again. I do 24 times 7. That gives me 168. I put that down here. And then does anyone remember the next process, what you do next? You subtract the 2. 178 minus 168 is 10. And we follow it again. We can keep going forever, but eventually this one will stop. 24 can't go into 10 because 10 is smaller. We have another number here, so we bring it all the way down. Then we figure out how many times 24 goes into 104, and it's 4 times. 24 times 4 is 96. We subtract 104 minus 96 is 8. There's no other numbers. I can't do this process again because 24 can't go into 8, and there's no other numbers to bring down, so we're done. This 8 here, in the past, you would just call this remainder 8. When you first learned this, your answer would be 274 with a remainder of 8. What that remainder is, though, is actually part of a fraction. And the fraction that it is going to be equal to 274, and then it's going to be 8 over 24. The remainder is a number, but the number is actually the numerator of whatever the denominator is, whatever you're dividing by, which is 24. So that's how long division works. Obviously, it's way easier to just, in your calculator, do 6584 divided by 24, and you get 274.3 repeating, which is the same thing as 274 and 8/24. But the reason why I have to show you this and remind you is because the way that we're going to now solve these polynomial crazy problems is that process. And to be honest, it is super confusing. Tomorrow we're going to learn a second method, which is a little bit easier, but it requires memorization For some of you, that's no problem. You can memorize like arithmetic and a method. Some of you struggle with that, so you might have to work hard on this type of problem. So what I'm going to do now is go back to just your side work. Now that we understand, or hopefully we now are bringing back some memories about long division. And we're going to complete the same problem again that we just did. The x squared minus 3x plus 2 over x minus 2. But instead of using the factoring method, we're going to use long division. So the way that these problems are usually given, they're not given like this. A lot of times they might be written like x squared minus 3x plus 2 divided by x minus 2. For whatever reason, they, in this section, WebAssign and our textbook, they like to show the problems using an actual division sign to start out rather than have it in fraction form, but it's the same thing either way. Instead of factoring it, instead of canceling things out, what we're going to do is use long division. So the long division sign is this. You put the first number, which is your numerator, inside, which this number is a polynomial, so it's going to be x squared minus 3x plus 2. And then you're going to put your divisor on the outside. We're dividing by x minus 2. Now, when you're doing this, the problems, the polynomials in the problem, always have to be in standard form, meaning the biggest exponent is here, and then it goes down the line to the constant number. This is in standard form. The biggest exponent is here, going down to constant. This is in standard form. It's the only way that it works. So the way that this process works is kind of similar to long division in that we have to see how many times this goes into this. So we first just look at the x numbers. And we have to think to ourselves, how many times does x go into x squared, which is almost like thinking x times what is x squared? X. So when you get that answer, whatever the answer is, you have to line it up wherever you said the answer was at, which would be this here, which is normally, like when we're doing long division, a place value. So your answer is x times, so you have to line it up with the x number. So what I do now, after you get that answer, the next part of the long division process is multiplying this number times this number. Well, x times x is x squared. We put it right underneath of where the squared is. But because this is not just a plain x, this is an x minus 2, we also have to do negative 2 times x as well. Negative 2 times x is negative 2x. We put the negative 2x underneath of the x category here. The next process in long division is to subtract. So we just take these first two terms here and we subtract them. X squared minus x squared, these will always end up canceling out as long as you're doing the process correctly. And then just be very careful with these minus signs and the negatives. Negative 3x minus negative 2x will end up being negative 3x plus 2x, which is negative 1x. I know this is confusing. Just bear with me. Now, at this point, once we have the negative x, we're also going to end up having this plus 2 here. So it's up to you if you bring it down now or if you deal with it later. It really doesn't matter. But now we're going to now look at this number here, x, and this number here, and think to ourselves, how many times does x go into a negative x? And that's kind of weird when you're thinking about variables. Like, how does this variable go into this? So think about x times what equals negative x? X times what equals negative x? Yes, negative 1. So I would put a negative 1 up here. Then I follow the process again. Negative 1 times x is going to be negative x. Negative 1 times negative 2 is going to be a positive 2. I should have already wrote this plus 2 here already. Sorry. I drew the arrow and forgot to write it. So now I complete the subtraction part of the negative x minus negative x will end up being negative x plus x, which is going to be 0. 2 minus 2 is also 0. When I subtract these things, I get no remainder. The answer is just going to end up being whatever's left up at the top. The answer to this is x minus 1, and if you remember from the beginning when we first did the problem, we got the answer as x minus 1 because we factored it, canceled things out, and that's what we were left with. This process, though, is like really confusing. It's not easy. Even when I'm doing it, I get tripped up. Like, okay, what do I do next? It's a process that you have to kind of remember, memorize, and hope for the best sometimes. So we're going to just try another practice problem so that we can kind of get the idea. And then we'll check it with our factoring process, which we already at this point should have mastered. So we're going to do another practice problem on our plain piece of paper. Let's try x squared plus 5x plus 4 divided by x plus 4. So we're going to set it up. We put the x plus 4 on the outside. We put the x squared plus 5x plus 4 on the inside. So when we go to start this problem, we always look at the x and the x squared first. And we think to ourselves, how many times does x go into x squared? And that's the way we would normally do long division with regular numbers. But because these are variables, it's kind of confusing. Sometimes you might rather think to yourself, x times what is x squared? And that would be what?
X times.
Yes. So we put an x lined up with the x number. And now it's time for us to do that multiplication part and then the subtraction part. So x times x is x squared, but we also have to multiply 4 times x as well. 4 times x is 4x, so I would put a plus 4x to show that it's a positive, and I line it up underneath of the 5x. Then it's time for the subtraction part of long division. The first part will always cancel out, it's supposed to, the way that the formula will work, it will cancel out when you subtract. But the second one might not always because the process will continue on usually. 5x minus 4x is 1x.
Just x.
So then,
Isn't it just x?
5x minus 4x is x, yep. Did I make a mistake?
No.
Oh. So I'm going to rewrite this plus 4 right here so I don't get confused with the process like I did last time. I forgot to write it. So I'm dropping down the 4 before I start the next part. All right, now that I have this, now I have to think to myself, okay, how many times does x go into x? I know that's weird. 1. Or you can think x times what equals x, and it's 1. So we put a plus 1 up top. And we multiply 1 times x, and then 1 times 4. 1 times x is x, and 1 times 4 is 4. We subtract, and these are all working out really nicely because these all end up canceling out nicely. X plus 4 minus x plus 4, or x minus x is 0, 4 minus 4 is 0. The remainder is 0, which means that this answer, was the other answer x? Oh, it was x minus 1, the other one. This answer is x plus 1. So to show you how to check your work with what we're used to doing, x squared plus 5x plus 4 over x plus 4. If I said simplify this from the past, you would take the numerator and factor it. The factors of 4 are 1 and 4 and 2 and 2. Which pair of factors add to be 5? Yep, 1 and 4. That means I can factor the numerator as x plus 1 times x plus 4. The denominator cannot be factored. It remains x plus 4. I can cancel out this x plus 4 with this x plus 4. 4 because they're the same. And I'm left with only x plus 1 as my answer. Now, a lot of you probably are thinking, well, that's great. Can we just keep doing that because it's easier at this point? And there are times when things cannot be factored, and that's why we have to learn this process. Okay? Yes?
Can I go say that?
Yeah, sure. All right, so let me figure out what I want to do next, because I don't want to do too many difficult questions. A lot of these are really hard. So I'm going to have you guys, I'll start it out with you, but I think that this one should be okay. So this problem here in our packet underneath of the long division, so we'll be back in the packet now, is 3x cubed minus 2x squared plus 2x minus 5, and we're dividing this by x minus 2. So we're going to start by putting the x minus 2 on the outside, and then 3x to the third power minus 2x squared plus 2x minus 5 all on the inside. Now this is going to be the first problem that doesn't end up canceling out completely. We will be left with a type of a remainder in this problem because it doesn't end up working out nicely. So when I go to start this problem, I look at this first x, and I look at the very first term, and I have to try and figure out how many times x goes into 3x cubed. That sometimes is difficult, so you might want to think x times what will give me 3x cubed. So you have to almost fill in the blank. So first of all, we need a 3 because in order for x times something to become a 3x, we need a 3. And this is x to the first power. X to the first power times what is x to the third power? Yes. So altogether, we'll need a 3x squared. We're going to put that on top of this one here because this term has the x squared. This is going to be 3x squared. Let me just backtrack and show you where I got that. X goes into 3x to the third power 3x squared times. And that's because x times 3x squared equals 3x to the third power. I basically need to insert all the things that are missing since x times 3 is 3x, and then x to the first power times x squared is 3x to the third power altogether. All right, once I do that, now it's time to take this and multiply it by each part. So I multiply 3x squared times x and 3x squared times negative 2. 3x squared times x is 3x to the third power. That should always happen to be the same thing. And then 3x squared times negative 2 is negative 6x squared. Once I have those ready to go, I can then subtract. 3x cubed minus 3x cubed cancels out. And then just be very careful here. You don't want to make a mistake. You can always use your calculator to help you with what the answer will be for how many. Negative 2x squared minus negative 6. Like if you're tripped up with that, just that part, then in your calculator, forget the x squared. You would just do negative 2 minus negative 6. It'll give you how many it is. When you subtract negatives, it's the same thing as adding. Negative 2 minus negative 6 is negative 2 plus 6, which is going to be 4. So this is 4x squared we have here. And I'm going to bring down this plus 2x so I don't forget about it. And I do the process again. But now I look at the x minus 2 and I compare it to the 4x squared. So x goes into 4x squared 4x times. And that's because x times 4x is 4x squared. So this will be plus 4x. And just recap, we can just make sure that x times 4x is 4x squared. That should always happen. And then we have to multiply the negative 2 by the 4x as well. Negative 2 times 4x is negative 8x. Then we subtract. 4x squared minus 4x squared cancels out. Just be careful with this. 2x, a positive 2x minus a negative 8x is 2x plus 8x, which is 10x. Okay, and then I'm going to bring down the minus 5 here. We can do this process one more time. Now we look at how many times x goes into 10x. So it's like x times what will give you 10x? What number do we need? 10. So we need a plus 10 here. And we multiply x times 10 and negative 2 times 10. So x times 10 is 10x. Negative 2 times 10 is negative 20. And we subtract. 10x minus 10x cancels out. And then negative 5 minus negative 20 is negative 5 plus 20, which is 15. Once you get down to this part, and there's no more numbers left in the original polynomial, and you look here and you're thinking to yourself, how many times can x go into 15, and there are no x's left, then you are done. That means that this number here is the remainder. But when we have our final answer, our answer is going to be this stuff up here. So it's going to be 3x squared plus 4x plus 10, but it also has this remainder of 15. What you do with the remainder is you add it, unless it's a negative. If it was a negative, you would subtract it. And it's 15 over the divisor, which is x minus 2. So you rewrite the answer from the top. That's your full answer plus or minus, if it's negative, the remainder. It's always going to be plus, actually. Plus the remainder, but always make sure to put the x minus 2, the divisor, as the denominator. And then that is the process.